Hello YouTube. Yes, I hope y'all liked my last video. If you do, just please subscribe or hit the like button. And yeah, this is next topic. We're talking about waves. And I just want to start with the Doppler effect. Is obviously Doppler effect as sound source approaches, pitch increases, goes away, and then if it were to go away, pitch would decrease. Just some common equations that I think would obviously be useful in just understanding waves in general. The period of a wave is equals 1 over the frequency. Also, another way you can find a frequency of the wave, besides the generic velocity times wavelength formula, is that you can just count the number of waves you have and divide it by time. And then going back to the Doppler effect, you can obviously find the Doppler effect if you are the observer, since which would be obvious here. It would just be f prime equals f v plus u over v. And then for the moving source, f prime is equal to f, this time 1 over 1 plus u over v. However, if these two equations were to be combined, you get something a little bit very neat here. You get f prime equals f f, and then inside 1 plus or minus u naught over v, and then 1 and then over 1 plus or minus u, or the sound, divided by the velocity. Okay, and then harmonics. Just to give an example, the first harmonic, if it was a closed harmonic, just L equals 1 over 4 times the wavelength. And then overall, if you just want to just notice a pattern, kind of make harmonics easier, if closed, just add 1/4. If the harmonic is closed, just add 1/4 to each harmonic. If open, just add 1/2. And then just other basic equations: k equals 2 pi over lambda, the wavelength, and then omega equals 2 pi times the frequency. Some basic graphs that you would know is obviously you have waves. You got you got a wave. Location is fixed, and it's given by the generic formula a as a function of time, a sine theta omega t, and it's distance versus time. And then if time is fixed, you just do a as a function of x. This time is a sine 2 pi over lambda x. And then the scale factor would just be k, which is 2 pi over lambda, which is obviously the equation that you familiarized with earlier. And then just kind of to conclude, moving waves, y as a function of obviously of distance and time, equals the amplitude times the cosine of kx minus omega t, if we were to move it to the right, and then if it were to be moved to the left, same thing, but change the sign. Thank you.